Hi everyone. I'm going to be opening and unboxing, reviewing this Sainsmart 37-in-1 sensor kit for Raspberry Pi and Arduino. Comes in this really cool little plastic box. It's a great kit, under $30 on Amazon. You get 37 sensors, under $1 a sensor. That's really nice. Some of them are pretty simple, some of them are a little more complex. And the big downside to this is you get very little to no documentation with it. So it's really up to you to find out what you can do or even identify these things and what you can do with them to make them useful. So go ahead and get started here. First up, we'll just start here in this corner. Very first thing that I got in my kit here was a rotary encoder. Got 5-pin header on it and your little rotary sensor there. You got your clock, you got your data line, and switch positive and ground. Second in our box here we have a tracking sensor. It's got a transmit and receive LED, so it can track a line of some sort. You got 3-pin header, you got your ground, you got your source, and your signal voltage, along with a sensitivity control potentiometer. Our next compartment, we have an RGB LED. It's very simple. It's just an RGB, red, green, blue LED soldered onto a board. The pull-up resistors are included on there, so you don't need a resistor. If you hook this up, it can go directly to an Arduino digital output, and it won't need any current limitation whatsoever. Basically, you got a 4-pin header. You got your common cathode or your negative. You got a anode for your red, one for your green, one for your blue. You have a Hall sensor. Measure the Hall effect or magnetic field. So this is a digital device that measures the intensity and direction of a magnetic field. You got a potentiometer there to adjust your sensitivity. And looks like you got your ground, your positive signal. It looks like analog and digital out. So I'm not sure exactly how that works, but maybe if I can find some documentation, I'll post a link for it in the description. Next, we have what they call a metal touch sensor. All this stuff comes from China, obviously, and a lot of what little documentation they have, or even their website descriptions, everything, translated from Chinese, probably by Google Translate, some kind of robotic translator. So you don't get a lot of information, even that some of the names come out screwy. But anyway, what you have here is you have a Darlington transistor, so a super high gain transistor. The base of that transistor is not attached to the device, but it actually folded up and bent over the top of the package there in order to create a pin that you can touch with your finger or connect to a plate, metal plate that you can touch with your finger to switch the transistor on and off. For instance, touch sensitive applications. You got your gain control right there to adjust the sensitivity, and a 4-pin header to connect it to your project board. Okay, the next item we have here is very small, basically just a thermocouple device, temperature control analog. This basically gives you a voltage output that is proportional to the temperature. And you got your basically, I think your ground and the signal out. Can't really read that. Not sure what the other pin is. But anyway, again, if I find documentation on that, I will post it in the description section. The 7th item in this kit we have here is a microphone element. Basically just analog audio input with your gain control. And a 4-pin header. It's got an AO pin, DO pin, signal, and a voltage in pin. The 8th item we have, if I can get it out here, is a tilt sensor. Basically, it is a mercury switch attached to a header. There's, I guess, an LED and a current limiting resistor on board, so when it completes the circuit you can get it to light up. Other than that, there's nothing really here. It's not very complicated. Single pole, single throw switch. Next item we have here is opto interrupter for rotary encoder or for linear limit switch. Basically you got a LED on one side and a phototransistor on the other side of this channel. When the beam goes across, it picks up the light from the other side. When something interrupts it, it opens the beam, and your phototransistor will detect that. Now, mine was actually, looks like it's been damaged a little bit. The header, I don't know how it came out like that, but that's the way it came in the box. So obviously before they packaged it, no other major damage, just that. Got your current limiting resistor and your bias resistor for your transistor, and your current limiter for your LED on side. So again, there's no need for any external resistors. Just plug it right into your Arduino. 10th item here is another type of temperature sensor. Looks like this one's digital, so we got a thermocouple sensor there on the end, and then it looks like well, they call this a digital temperature sensor, so I'm guessing it maybe goes to 80D converter or something of that sort. Again, you got your gain adjustment there. So I'll try to find some documentation for this item and post that in the description as well. Okay, next up we have our passive buzzer. Just a piezo buzzer element or piezo transducer mounted to a board and a header. Nothing to it. So since it is a passive buzzer, you will need to provide an oscillating signal to it. Just applying voltage to it will not give you anything. You need to you need to power this with an oscillator in order to get any sound out of it. Next up, we have one of my favorites here. It is a digital temperature sensor. It has a DS18B20 sensor on it, and that's about it really. An LED, current limiting resistor, and a header. The cool thing about this, and I'll post links on the video here, but taken from the data sheet here, I'll just read this to you. The DS18B20 digital thermometer provides 9-bit to 12-bit Celsius temperature measurements and has an alarm function with non-volatile, user-programmable upper and lower trigger points. It also communicates over a one-wire bus, which by definition requires only one data line and ground for communication with the central microprocessor. Each individual chip has a unique 64-bit serial code so that you can use multiple chips on the same single bus. It's just all around very useful, very awesome component using temperature measurement. You can set your alarms, you can decode the output, which will be in digital form, and it gives you direct Celsius temperature instead of Kelvin or Fahrenheit, which is almost completely useless in electronic applications. All right, up next we have our active buzzer. Active buzzer is the same as the passive buzzer, except it has an oscillator on board, so you don't need to use an oscillator. All you have to do is apply voltage to get sound out. You don't really have any control of what that sound sounds like. You live with it or not. It has a nice little sticker on here. I don't know if you can see it. I'll try to get this thing to focus. Remove seal after washing. I do not recommend washing this. I'm not sure why you would need to wash it, but I have a feeling that's not what they meant. Next up, they say this is a knock sensor. I guess it detects like if you're building a robot and it bumps into something. Not sure what they mean by knock sensor, but probably just me. I'm kind of new to this. So anyway, got some sort of gizmo on the front of it. Looks almost like a reed switch, but it looks like it's wire wound. It's like a coil inside rather than a reed. All right, up next they have a tilt switch. I'm guessing this is more of an analog or digital solution than a mercury switch. I'm not sure actually what it is under there. They have it wrapped up in some sort of shrink tape. So I can't really identify the component that's on board. It's mounted in an angle. So I'm guessing it's some sort of Hall effect device that can detect the angle of tilt rather than just a mercury switch, which is more of a digital kind of yes or no type signal. Item number 16, we have here basically just a reed switch. You see that there? Little tiny reed switch, single pole, single throw, connected to 2 pins of a header through a resistor. Reed switch detects a magnetic field. Basically, you have 2 little filaments inside this glass bulb. When it comes in contact with the magnetic field, the little metal filament bends towards the magnetic field and closes the switch, and that's what you get. So it won't measure the strength of the intensity or the polarization of the field. It basically just tells you if there is a field present or not. This is useful for limit switches where there's no contact. It comes near a magnet, it closes. So if you have something that's in motion in robotics or a linear actuator or a slide of some sort, when you put a little magnet on there, when the magnet comes near the switch, it knows it's reached the end of its travel, and you can use that for detecting position or, again, for defining the limits of motion. Next, we got here a finger pulse sensor module. Looks like it's got an LED on it. It's got this wacky little sensor on it. Looks like it's got two wires exposed over a piece of plastic or acrylic or something. So I'm assuming you put your finger on there. It measures the change in conductivity of your skin and pulses the LED along with your heartbeat. I don't know. That's my guess. Next, they got this little handy. I can't get it out. Complain about this box they sent in. All right. Anyway, looks like some sort of LED. Just a 2-pin anode cathode connected to a 3-pin header in some manner. They call this the colorful auto flash. Don't really know what that means, but hook it up and see what it does. Item number 19. We have here another LED. This one has 3 pins. It's got a common cathode, 2 anodes in there. So basically you got 2 LED elements inside one package. It's a bicolor LED, red and green. So again, the current limiting resistors for both sides are on board. All you need to do is hook up your cathode to your negative, and then you got your 2 anodes for positives, one for red, one for green. The next item is another Hall sensor used for detecting magnetic fields. This one does not have a potentiometer on it for making any adjustments to gain, so anything of that nature may need to be done externally. It does have an LED and a current limiting resistor, so looks like it might be more of a digital, just kind of a yes or no device, maybe a alternative to a reed switch. Our next component here, not a sensor, but 3701 sensor kit, but not all these are sensors. But anyway, we have here a tricolor LED. Looks just like the bicolor LED, except it's a smaller package. Same 3 leads with a common cathode. It does have both current limiting resistors on board, right into your header. I'm assuming the third color is when you have both chips on at the same time, and I don't know what those three colors are. I'm guessing red, green, and amber, but I could be wrong. Plug it in and find out. Alright, next we have our obstacle avoidance board. It's got an infrared transmitter, infrared receiver on the same board, both pointed forward, so if it's on a robot or something that's moving, once the photo transistor there at the top of the screen detects the infrared light being received by the emitter at the bottom, so if it's reflecting off of something, it gives you a signal back, and you can use that for whatever you want. All right, next we have our PS2 joystick, PlayStation 2. You see it's got a rotary encoder for the X, rotary encoder for the Y, and I can push it and hear the click. It's got a micro switch underneath it. And you see here in the header you got your ground, you got plus 5 volts in, then you got a voltage out for your X, voltage out for Y, and your switch output. Next we have a just a push button module. Is a little micro switch push button, kind of a long actuator, which is nice. They have this labeled online as a shock sensor. I don't think that's what they meant for it. There is a shock sensor in here, and they have that labeled as a push button, so I think they just switched them. There is a resistor on board. I'm not sure what purpose that serves. But anyway, there you go, push button. Then we get our next item, which is an RGB LED. This one's pretty nice. I like it. It's got the 3 current limiting resistors on board. Again, same configuration, common cathode, and then a pin for each individual anode, one for red, one for green, and one for blue. 5-volt DC relay module. Single pole double throw, so you got your common, your heel block in the center of this terminal block right here. It's terminal strip, and then one side's are normally open, one side's normally closed. They're labeled on the board, which is nice. Got your diode in there for DC to help protect your Arduino, although I would not hook this up directly to your Arduino outputs. Relays do have, they are an inductive load, so as the magnetic field created by the relay coil collapses, it's going to send voltage or send current back into the Arduino. That's what that diode's supposed to protect against, but just to be safe, it's better to feed this optically used as separate power supply. But anyway, there's your input pins as well. Okay, up next we have a high sensitive voice sensor. It's got a microphone element on it, a little bit larger than the other one. You got your potentiometer there for adjusting gain. Looks like the same amp, same header. Everything looks identical. Maybe a different element there, maybe just a little more sensitive microphone. I'm not really sure what the difference is between the two. This next one is very interesting. I'm not really quite sure how this one is to be used. I'm going to try to find some documentation for it, and again, I'll post a link if I do find it. I'll post a link in the description section. Basically what we have here is a reed switch, just a regular single pole, single throw reed switch. On the end there, we got 4 resistors, variable resistor, and then we got 2 LEDs with current limiting resistors on board. And so I'm guessing maybe one to indicate on, one to indicate off. That's a guess. I'm not sure. I'll do some more research on this and post a follow-up. So we have this guy, which it lists as a flame sensor. I'm guessing it's optical device that's going to pick up UV or infrared elements of flame. We used to use those for flame detection in boiler systems back when I was a lot younger than I am now. They weren't this simple. They were a lot more expensive, a lot bigger, and probably not as cool. In the next compartment, we have our infrared transmitter. There's some just infrared LED mounted to a board. I don't see any current limiting resistor on here, so that may be necessary. But this is going to be useful for all your infrared remote control applications. We got our laser emitter LED. Need to do something involving a laser. I'm assuming it's a red laser, but I haven't tried it out to find out what it is. Anyway, laser emitter. The next item is interesting. There's two of them. They're on the same board, but the board is scored so you can actually separate the two. It's just a mercury switch and an LED with the current limiting resistor on board. There's a 4-pin header for ground, plus 5 volts. Signal in or out, I'm not sure. And then for the last one, L for the LED. Yeah, I'm not sure what to make of these, but they call it, on the documentation, it calls it either a magic ring or a magic light cup. Whatever that means. I don't know. Poorly translated, I think. Anyway, there you go. The next item is the infrared receiver. Pairs with your infrared transmitter for remote control applications. Basically a photo transistor. It's got a resistor and an LED on board, so you see if it's receiving, the LED should light up, and a 3-pin header for connecting to the transistor. Okay, next up we have this little blue guy, which is a humidity sensor. So got your 3-pin header there, ground, VCC, and signal out. So this can measure humidity, useful for rain detection, for hydroponics, snow detection, etc. Into the home stretch here, we have our LDR, or light dependent resistor. Basically just a little photo sensor. Resistance varies with light input. Not much to it. There's a little pad resistor on it and 3-pin header. Last we have what I believe to be our shock sensor. Online documentation will show it incorrectly labeled as a push button module, and then they show the push button module labeled as a shock sensor. So I believe this is the shock sensor right here. 3-pin header and a resistor on board. So I'll try to find some documentation on how to utilize this device. And there you have it. That's the Sainsmart 37-in-1 sensor kit. Again, under $30 from Amazon. I've seen it as low as $24, well under $1 a component. The quality is very high. Everything's soldered on very well. Good choice of components. Everything's very high quality and at an excellent price. I'll try to provide as much documentation as necessary as I can find, since that's the only thing that seems to be lacking from this kit. And if you happen to see anything or know of any links to useful information, feel free to leave a notice in the comments. And thank you very much, and please like and subscribe to our channel. Thank you.